All right, this is lesson 7.3e, and today we're going to be graphing quadratics, and we're mainly using our calculator to do this. So if you don't have your TI 84 calculator, that's going to be a problem. See if you can acquire it. Pause this video first, because we're going to be doing a lot of things with the buttons that if you don't actually press the buttons yourself, you might not really grasp hold of what needs to be done. Let's start with this warm up here. So it says solve for the zeros of the following by factor boxes and the zero product property. So you should be able to do this. And then there's some questions here. I don't know why it jumps from question 1 to question 3. It's a real good question. You should be able to answer all these questions. And then from there, we'll continue on with the lesson. So go ahead and do those. So taking a look here, I went ahead and found my magic numbers here. And it was -5 and 4, used a factor box. Once I had that done, you set this, and I didn't really write that, but set it equal to 0. And then you can say, well, when are the factors equal to 0? When is x minus 5 equal to 0? And then I did a little solving, and I got when x is 5 as well. And that, you maybe don't need to do the solving. You can just look at this and say, oh, if x is 5, then that would be 0, as well as here. When x is -4, that's going to be equal to 0, but you can also solve it algebraically. Number 3 here, what is the shape? It's a parabola. What do x and y represent? This one might have been a little harder to answer, but x and y represent all of the points, right, or all the solutions on that parabola, and there would be an infinite number of them. Where are you on the graph when y equals 0? That's the x-axis. What are the coordinates when y equals 0? Well, those were the roots or the x-intercepts or zeros, whatever you want to call them, that we already found. And then what is the vertex? Now, I decided to use h equals -b over 2a, and I used the original equation that was in standard form, but you certainly could use h equals r1 plus r2 divided by 2 and get the same h result. It should be 1/2. And then from there, you can go ahead and you can find k, which is a weird number, -20.25. Therefore, my vertex is 1/2 and -20.25. It did not ask us to write it. Oh, it did say write the equation in vertex form. That's fun. What's that? So that would be y equals, and the a value would be the same as before, which was 1, so it doesn't really matter. X minus h squared plus k. Oops, I'll do a minus sign there. Minus 20.25. So that's vertex form. So that's what that looks like. So there is the warm-up. Now, most of this lesson here, we're just going to be fuddling around on our calculator and learning how to do this. We already know for this problem number 1, it's the same problem that was in the warm-up. So we already really know the answer, but now we're going to have our calculator do it for us, okay? So again, here you need to have your calculator. You need to be pressing the buttons. Watching me press them is not the same thing. I've been around a long time, and sometimes kids, they just don't ever have a calculator, and so then they borrow their friends or get one from me on the day of the test, and they have no idea how to use a calculator because it's not easy to use, okay? You have to practice it. So type in the trinomial. So the first thing we're going to do is we are going to, and I'm going to go over to our calculator as we do these things. I'm going to move this calculator over here. All right, so if you go to y equals, I have something in there. I'll clear that out. If I type in x squared, as you should, minus x minus 20. So there it is. And I hit graph. Let's see. Now, here I can't quite see it. So if you want to see the graph completely, you want to go down and see that vertex. If you go to your window now, so really what I want to see is further down, right? Further down, I want my y values to go beyond what it's showing me right now. Right now, my y values are being shown here and here, y min, y max. Actually, no, the vertex is -20.25, right? Because of the warm-up that we did. So I'm just going to change this y min to -25. Otherwise, you just have to guess if you don't know what it is and try to see if you can see it. So now I can see the vertex, I can see the roots, I can see all those things. But it's asking me here to find the zeros. Okay, so there's 2 zeros. So I'm going to do this process twice. So it says for step B, select 0. So I go to second and calc, and I go to 0, which is number 2. And then it's asking for a left and right bound. And as shown here in the little graph, your left and right bound is going to be like a point above the 0 and a point below the 0 in this case, because you're basically trying to help your calculator sort of sandwich where this 0 is. So it's asking for something just to the left and something just to the right, like that. So it's asking for the left bound. So the left bound for that 0 that I'm talking about, you have to hit the left and right arrows to move your cursor. So left bound will be somewhere here, and right bound will be somewhere there. And see how you can see oops, it's not going to work. It's going to be hard for me to write. I don't think I can write on my screen here for the calculator. But see how you can see the little vertical lines there and the little arrows that are on the top, just kind of creating like this window or this little rectangle that you're sandwiching it in. That's your calculator trying to determine where the 0 is. And then in terms of guessing, just guess something closer to it. Usually you can just hit enter and just ignore that, but just something a little closer. And then your cursor, when you hit enter again, your cursor should flash on that 0. And it's telling you at the bottom of your screen, the 0 is x is -4 and y is 0, which we already knew that, correct? So that we did that in the warm-up algebraically. For the other 0, no, I actually said in step F there, which the graph kind of covers. Something's a little messed up with our notes there. But if you go to your table, you can also see the 0 by looking at your table. At that third line down, -4, 0 is the 0. So you can see it that way as long as it's a nice number, right? But if it's a decimal, your calculator is not going to show you that. So the table can work sometimes, but not always. You're also supposed to find the other 0. So when you do the other one, you go to second calc, 0. And now if I want to find the one that's over here, and this is what gets students sometimes a little mixed up. So now if you're looking here, you're looking at this thing, the 0 you have is right here. The left bound is going to be the left of it, which this time is below it, and the right bound is above it. So try not to think of things as above and below. Try to think of them as to the left and to the right of the thing that you're trying to find. And we're trying to find that 0. So our left bound is something to the left of it. So now going back here, oops, to my calculator. So left bound, this is good for my left bound. Doesn't have to be super close. Right bound, something to the right of my 0. Guess, I can try to get a little closer. And it tells me my 0 is 5, 0, which we already knew that as well. That was already determined. Now, as we go down to the bottom of the notes page here, it talks about finding a minimum or a maximum. So now find the minimum and or the maximum for, again, the same equation. We already actually know the minimum. The minimum is the vertex, and we know the vertex is h is 1/2 and k was -20.25, right? So now here it's asking you to play around and adjust your window. Now we already did this, but if you haven't and you can't see your vertex, you're going to have to go to window, pick some other minimum value. I guess when I did it in my notes, I did -40, but just enough so you can see that vertex, okay? And then the next step, all right, step B is to regraph it to be sure it's visible. We did that. Step C, now we're going to find the vertex, which is a minimum. Now, if this was an upside down parabola, we would be finding a maximum because it would be the highest point, but this is the minimum. So second calc, I'm going to find a minimum. That's number 3. And the left bound, so no, remember, we're trying to find the vertex. So left bound is something to the left of the vertex. This point over here is fine. Something to the right, or right bound, just something past the vertex. Maybe here's good. Guess, okay, I'll get a little closer. And then it tells me my vertex is, now here my calculator is saying 0.499999. I don't know why it does that instead of saying 0.5. And there's some of you who probably just did this problem in the same 0.50000001. It just sometimes errors by a tiny decimal. I don't really know, again, why that happens. But it is now telling me the x value, which is h, is a half, and the y value, which was our k, is negative 20.25. So that's kind of how you go ahead and find that. The question on the bottom here says, what cases could you look for a maximum rather than a minimum? So maximum will be, when parabola is upside down. And that is when a is negative, right? Because that is what causes the flip over the x-axis. All right, now you get to try on your calculator. Now, again, this problem is possible to do on decimals too, for sure, but we want to know how to do it on a calculator because that's what we get to use on tests, including important tests like the AP tests in the future. So that's why you want to be able to do it here. So go ahead and do this problem, both the finding the roots and the vertex, as well as writing it in factored form and vertex form. Do all that yourself. All right, so this is what I have for the roots and the vertex. A comma there, so it looks a little bit better. And then also factored form and vertex form. Again, if you're having trouble with your calculator, it could be something that, as I'm explaining this, you've got something else going on, and so you're not able to get this done. So definitely share with me what the error is so that I can figure it out with you. I'm pretty good at figuring out what is wrong with your calculator or whether we need to reset it or not. I'll just go one time through finding the roots here in the vertex, and if you're good with this, you can just ignore it. But if I'm going to find the roots, I go second calc. I find a 0, number 2. If I find the one on the left here first, we're going to go over here. Left bound is to the left. Right bound is to the right. And then something in the middle, I'll guess right there. And it tells me it's negative 2.7655. So I rounded to negative 2.77. If you are doing the other root, I say second calc again. I go to number 2, which is a 0. A left bound is going to be something to the left of that 0. So I'm looking at the 0 over here. So left would be somewhere like that. The right would be somewhere to the right of it. Yes, that looks good. And it tells me it's 1.265, so that's why I rounded it to 1.27. The vertex, now in this case, this is a maximum. The vertex is the high point, so it's a maximum, which is, so if I go to second calc, that's number 4. For the vertex, a left bound, something to the left of that vertex would be somewhere like there. To the right, a right bound somewhere here. Guess I'll just pick something kind of in the middle, somewhere about like that. And it tells me it's negative 0.749999, so negative 0.75. And it tells me the value is 8.15. And then I wrote them there in both factored form and vertex form. Last question here, and this is just kind of the story problem connection that we want you guys to be able to do. All right, so Jordan launches a chuck-it ball for his dog Killer in the backyard. The ball flies through the air and lands on the ground, and Killer retrieves it. This is like my dog. She doesn't actually catch balls in her mouth ever. She just lets it bounce or land, and then she deals with it after that. She also doesn't return the ball to you. She just bites it, chews it, runs away, goes into the bushes. So it's not really that much fun. You have to kind of have many balls if you want to keep throwing balls with her because she doesn't actually retrieve them. The chuck-it ball's projectile can be measured or modeled by this equation right here. Okay, use your calculator to find the roots and the vertex, and next sketch the quadratic and the axis labels. The vertex, the roots, the units are in height, or the units of height are in feet. And actually we know that, remember how we did that other problem there, that negative 16, that is indicating this is a problem that's in feet. and seconds, okay? Now I'm just gonna, before we get too involved with doing this problem, I'm just gonna extend my little line here, and I'm gonna draw this parabola. I don't know any of the numbers, right? But I'm gonna go like this. So it's kind of doing something like this. This is good enough. I know at the beginning, the y-intercept, okay, is 7.5. And the reason I know that, first of all, it's on your formula sheet. We haven't really talked a lot about what standard form means, but that's 7.5 at time 0, right? If you put a 0 in here and a 0 in here, these would all become 0. And at when x is 0, y is 7.5. So that chuck it ball, when it's leaving, when the ball is leaving the handle thing that he's throwing it with, right? You are at right here, 0 and 7.5, okay? But I want to know this root, even though that root starts before time starts, so that doesn't really mean anything. I should label my axis. Time is in seconds. Height is in feet. Good luck writing sideways on a screen. Wasn't terrible. But I want to find, again, the roots, which is this root, which doesn't mean anything, but I'm going to find it anyway. This root and the vertex. Now, the vertex is going to represent this high point, right? When and how high does the ball get? And then this root right here is going to represent, this is going to be 0. This is when the ball lands, because x-axis is time. So that's going to be when the ball lands on the ground. It asks here then for a, what are the roots? So that's when the ball is going to be landing, as well as this root over here on the left, which doesn't really mean a whole lot. And then it's going to ask, what is the vertex? So let's go ahead and get our calculator, and we are going to type this guy. And we also could do this problem algebraically, but we're doing it with our calculator today because that's what this lesson's about. So I'm going to put negative 16x squared. This helps to be able to type. Life's a struggle, and you just gotta keep going on, you know, even when you can't type, plus 7.5. So there's my equation. And now I'm going to go and find the roots. Now again, so when we graph it, well, oops, that's not what I wanted to do. Just graph. First of all, I have my window kind of in a weird spot, so I can't see that. One thing, just to get this window back to normal, because now we've moved it around, if you go to zoom and do number 6, this kind of resizes the window. Now that didn't really help us a whole lot, right? But one thing I can definitely see is that, I mean, I don't need the x-axis to go from negative 10 to 10 like it is. I also need to see higher for the y. So when I go to window, you can do some zoom out things, but it just always really sizes the window weird. I'm just going to change my x min. Like, I don't need to see way back there. I'm just going to go from negative 1 seconds to like maximum of like 5 seconds or something like that. It's going to land, that ball's going to land before 5 seconds. And then my Y max, I need to be higher. I'm just going to go to 50 just so that I mean, he did not throw it higher than 50 feet in the air. Probably more like, what does that look like? About 25 feet or something like that. But at least I can see my parabola there a little bit better. So now when I find the roots, I'm going to go second calc. Those are called zeros as well. I'll find the one on the left first. Now remember, the one on the left doesn't really mean anything in the context of the problem because this happens, like this is time before he threw the ball, and that doesn't really exist in this problem, but we'll find it anyway. I hit enter. You might need it if it asks you to write it in factored form. And I'll go maybe right here. Guess I'll just get a little closer. Okay, so that 0 is negative 0.22. 3, let's say, and we can write that in on our notes. 223. I'll write it here too. Negative 0.223. Yeah, it's really sloppy. All right. And the other root, if we go back to our calculator, we go second calc. We're going to find a 0 again. That's number 2. And it doesn't like me holding it. All right, so left bound, that's probably fine. Right bound, somewhere down here. Do I want to guess? Not really. I'll just go there. And I think something went wrong because I don't like where my little line is. I think it's going to give me an error. Something happened there when I picked my left bound because I was not to the left of it. All right, let's do this again. Left bound, that's to the left. Right bound, that's to the right. Guess, how about right there? All right, so 2.098. Let's say 2. And I did say 2.098 in my notes. Let's just do that. The vertex, is that a minimum or is that a maximum? Since it's a high point, right? He's throwing it up in the air and the parabola is upside down. That is going to be a maximum. So second calc, maximum is number 4. And by the way, if you do it the other way, it was not going to pick the right point. It just won't know. So my vertex here, I need a left bound. So maybe about here, right bound, somewhere over here. And I get 0.937 for my H and my Y. I get 21.563. And actually, it should be an 8. 21.563. That goes right here. Again, what do the roots represent? The roots, well, it depends on which root you're talking about. This root means nothing. You don't mean anything. You happened before the problem even started. And then this one is where the ball lands on the ground. It reaches the ground. The height is 0, right, when the seconds are this. So the ball's only up in the air for a little over 2 seconds. What is the vertex? The vertex represents the time of max height. So when it asks, when did the ball reach its maximum height? It would be 0.938 seconds. And then this is the max height because the Y value is the height. So max height. All right, that's it for this lesson. But doing those problems in your calculator, usually the calculator ones are going to have like ugly numbers, and then the ones we ask you to do algebraically are a little bit nicer numbers. You can solve these problems algebraically. The calculator is very nice to use as well, and we're just trying to give you all these different ways to do the same things.